Good day. Well, we've chugged through the section on electrochemical cells, so it's now time for a brief review and trying to boil down the things that you should understand. And it also references the pages if you feel the notes aren't thorough, you can read through the textbook. So we have to know the anode is an electrode. This is the electrode where oxidation always occurs, and that means that we are looking at electrons being generated there. Cathode is always the site of reduction, and of course anode comes from the word anions and cathode comes from the word cation. Electrolyte just means a conducting solution from last year, and it's essential. It's what completes the circuit. So you have an external wire connecting electrodes, and in between the electrodes you will also have the electrolyte. And we need mobile ions, that means soluble ionic compounds that are going to work. The salt bridge, this is typically a liquid containing an ionic solution, hopefully with inert ions, that means ions that aren't going to interfere with our desired reaction, and they prevent a polarity buildup and allow the cell to function. Well, electrochemical cells, you should know they're also called voltaic cells and galvanic cells, and they involve spontaneous redox reactions. That means when you calculate the E0 value, it will have a positive cell potential. Oxidation always happens at the anode, reduction always happens at the cathode, so the flow of electrons is always from anode to cathode. Identifying redox reactions. Well, that goes back to an earlier section on predicting redox reactions. You have to use your table of reduction potentials. You come down the left to find the chemical that's highest, so it's most likely to be reduced as the strongest oxidizing agent. You do the same thing on the right of the chart, except you come up from the bottom on the right and see what you hit first, and that is the most likely chemical to react, and you combine them to get your overall reaction and to calculate your cell potential. You should have made notes on different types of electrochemical cells. So you have dry cells, and these are often in the kind of batteries that we will run around and buy. And these are some of the electrolytes we may find, and it's called a dry cell because it has a paste in it. Primary cells are non-rechargeable. That means once the reaction's over, we don't have a reversible reaction where we could run electricity into it and get back to the reactants and then use it again. Secondary cells are rechargeable. It means they do involve reversible reactions. And so in one way, when the reactants are reacting, they make electricity. Once they're used up, you can run electricity back into them and regenerate the reactants and use it again. And nowadays we have all kinds of rechargeable batteries on devices like phones, and of course the car has used a rechargeable battery for many years. Now, fuel cells are a separate category that we've talked about, and that's simply, yes, they're electrochemical, yes, they make electricity, but we keep supplying them with at least one of the reactants, and away they go and continue to produce electricity. Now, those are all positive things, making electricity and be very useful. Corrosion is an example of electrochemical reaction that has negative consequences, that it's going to be damaging things that contain iron or steel. So it's important to know different ways of preventing corrosion, and those include cathodic protection, where you make the iron the cathode by attaching a more reactive metal to it. By more reactive, that means a metal that is more easily oxidized, and that's called the sacrificial anode, and that could be magnesium or zinc. We can also galvanize iron, and that means coat it completely in molten zinc and let it harden, and therefore zinc creates a physical barrier blocking things like oxygen and water, but also a chemical barrier because the zinc is going to behave like an anode. So hopefully that's a reasonable summary of what we've been up to, and of course this is more like an overview. You should go through your detailed notes, make sure you have total command of these topics.